हेलो एवरीवन, दिस इज योगेश एंड वेलकम बैक टू दिस चैनल कोड अप विद न्यूटन स्कूल। और हम लोग आज बात करने वाले हैं प्रॉब्लम ऑफ द डे, राइट? सो द नेम ऑफ द प्रॉब्लम इज, बट वहां जाने से पहले एक इंपॉर्टेंट बात, इफ यू आर न्यू टू आवर चैनल देन प्लीज सब्सक्राइब द चैनल एंड आल्सो प्रेस द बेल आइकन so that you will be notified first when we upload our new videos, right? So let's start. So today's problem is bi-connected graph, right? So name of the problem is bi-connected graph. So by reading the problem the title, we are able to know that this problem is of a graph, right? So let's read. So it's given a graph with n vertex and e edges and an array denoting the edges connected to each other. So we are given some vertex, some edges, an array which is containing the number of edges, that is all the edges, right? So let's see what is that array and all, right? And check whether it is bi-connected or not. So we have to check what is the meaning of this bi-connected. So in Wikipedia it's given that it is a connected and non-separatable graph, meaning that if any one vertex were to be removed, the graph will remain connected. That is, if we remove any one vertex, right? If we are removing any one vertex from the whole graph, the graph will remain connected. That is, it will not be disconnected. For example, like I will show you an example. So let me show you an example only. So for example, we have a graph like this, right? We have a graph like this, correct? Now if I remove this vertex, if I am removing this, then we can see that our graph is disconnected. That is, this is a separate part, this is a separate part. That is, our whole graph is divided into two parts. For example, we have a graph like this, we have a graph like this, right? We have a graph like this. Now if I remove this node, right? So if I'm removing this node, then these two edges will also get removed, right? But now we can see that we have only one component, right? We have only one component. So it means that the condition is true, which it was written is that if we are removing any one vertex, then graph will remain connected. And we can see that when I remove this guy, right, this node was there, right, this vertex was there, when I remove that vertex, the whole graph is still connected, correct, in a single component, not in 2-3 different disconnected components. Not, it is a single component, right? But if we remove a different node, that is for example, if I'm removing this guy, right, if I'm removing this guy, then we can see that our graph is divided. That is, it is not a single component, it is in two different components, right, disconnected components. So this is the meaning of bi-connected graph, correct? So given graph is undirected, so it is not directed graph. So yeah, this is given. Now what we have to do is that we have to check whether a given graph is a bi-connected or not. So if it is bi-connected, let me check what is the output we have to print. So a graph is given, above graph is bi-connected. So if it is a bi-connected, then we have to print 1. If it is not bi-connected, then we have to print 0. So here what I told, so in current state, so this is not a bi-connected because it is divided into more than one components, right? But the earlier example which I showed, that is bi-connected because the whole part was in a single component. Okay, so 1 means bi-connected, 0 means not a bi-connected, right? So yeah, so let's not see these examples. These are very simple examples. Want to show, like I have also currently only I showed you some example, right? But let me take one more example, right? Like wanted to show you something like if you have a graph like this, right? If you have a graph like this, right? So like you can see this part is a part of a cycle, right? This is a part of a cycle. So it is clear that in this cycle, whichever node you are removing, whichever vertex you are removing, there is not going to be disconnection. That is, the whole part will be a part of a single component only. For example, I am removing this guy, then it is cool, right? Because we have a single component. If I am removing this guy, also we have a single component. If I am removing this, again connected component, right? Single connected component. But after this, that is, if we are not thinking of this cycle, if we think of these three guys, right? If I am removing this, then it is divided into two parts. If I am removing this, again divided into two parts. But if I am removing this, then single part only, right? So the problem was with this guy and this guy, right? The problem was with these two guys. These two guys are making this graph as disconnected, right? But we want in such a way that if I am removing a single node, then whole graph will be a connected component, correct? So how we are going to solve solve this. Like our graph is given and we have to check whether it is biconnected or not. ठीक है, ये हमें निकालना है. So let's see the first input. So it is given that we have given two arguments n and e, that is number of vertex and edges, an array of length 2e. Array of length 2e is given, which return 1 if a graph is biconnected and else 0. So what is this array represent? So for example, we have an array like this, 1 2 3 and 4, 2 and 5, for example, like this, right? It is written 2e. So if we have 3 edges, okay, 3 edges, correct, sorry, it's my mistake. If we have 3 edges, that is if e ka value is 3, then we will have 6 number of vertex, 6 number of elements in this array. So 1 2 2 3 3 4 4 and 5, 1 2 3 4 5 6 7 8, it's 8, right? So we have to take 1 2 3 5 6, only 6 elements. So I'm taking like this, correct? So we can take like this also, or we can take anything. Let me take a different one only. 1 2 4 and 5 and 3 and 2, right? So it means that these two guys having an edge, 2 4 is having 2 4 and 5 is having an edge, 3 and 2 is having an edge. So if I draw the tree, that is graph, 1 and 2 is connected, 4 and 5 is connected, 3 and 2 is connected, right? So this is our tree graph, correct? So like this, the input array is given, the adjacent datas are connected to each other, that is edge is given, 1 and 2 having an edge, 4 and 5 having an edge, 3 and 2 is having an edge, like this. Okay, so I think input is clear with you all guys, right? So let's move on to the solution wala part. That is, first of all, we have to create an adjacency list, right? Because an array is only given which is containing 2e elements, so that is of no use, right? So before starting a solution, we have to create an adjacency list. And I think that thing, you know how we create an adjacency list, correct? After creating an adjacency list, now we have to think something, right? Like how we have to perform. So here we saw that this was not having an issue, this was not having an issue, this guys were not having an issue. The issue was with this guy and with this guy, right? Now how we will identify, like if we do we have these guys in our graph? If these guys are there in our graph, then it means that no biconnection or biconnected graph. So this is not a biconnected graph, right? So how we will identify those guys, correct? So one thing I can check here is that if we have any node with degree 1, I think you know what is degree. Degree means, for example, if we consider this node is having degree 2, that is it is connected with 2 different elements. If we consider this node is having degree 3, that is this is connected with 3 number of elements, right? 3 number of different nodes. So if we have any node, any vertex with degree 1, then it is sure that we are not going to have biconnected graph. Why? Like in this example, we can see that this node is having degree 1, that is this guy is connected with only 1 element, right? Or 0 element. It can happen 0 also. We can have a node here as well, right? Which is not connected to anyone. So in starting only it is disconnected, correct? Starting only it is disconnected. So if we have any node or vertex, right? Any node or vertex with degree as 0 or 1, these are the two conditions. If we have a degree of 0 or 1, then it is sure that this is not in a biconnected, that this statement which was given, that is not satisfied here. So output will be 0. Now how it's happening, let me explain. So for example, let's consider this node only. This node is having the degree as 1, right? So this guy is connected with this guy, right? This guy is connected with this guy. Now if I am removing this guy, so we can easily see that our graph is now divided into 2 parts, right? So that's why this was the reason. Let me explain you with a more example. Like we have a graph like this, correct? In this also, this guy is having degree as 1, this guy is having degree as 2, this guy is having degree as 1. So let's consider this guy having degree as 1, right? So it's adjacent, so we have to remove the adjacent element only. If I'm removing the adjacent element, so our graph is divided into 2 parts. That is, it is no more in a single component, right? It is more than a one component, that is 2 3 something like that, right? So let me show you an example for true wala part, right? So for example, we have a node like this, right? We have a diagram like this. then we can see that if we are removing any one of the guys, right, if we are removing any one of the guys, then it's definitely sure that we are going to get a single component, that is we are getting the output as true, right? So yeah, this was the overall intuition. Let me show you the code wala part. So basically I'm checking if my number of node is 2, right? So for example, we have a node as 2 and we have a single edge, right? We have a single edge. So here we are getting what? This node is having degree as 1, this node is having degree as 1. So it can happen that our code will return this as false, but it is not false. If I am removing this guy, then we are getting only single component, right? So that's why this was a base case. So I have checked if n is 2 or edge is 1, then return 1. Otherwise, take a graph that is adjacency list के लिए 2D vector, run a loop for the 2e times, because it was told that this array is of size 2e. Get the two data in push into the graph, that is g of u may push karna hai v, g of v we have to push u, right? So adjacency list is prepared. Run a loop in an adjacency list, check if size is less than 2. So what basically it means that, for example, we have a graph like this, right? This is 1, this is 2, and this is 3. So adjacency list of 1 is 2, adjacency list of 2 is 1 and 3, adjacency list of 3 is only 2. So basically its size denotes the degree, its size denotes the degree, correct? Its size denotes degree. The size of 1 is 1, size of 2 is 2, size of 3 is 1, right? So it denotes a degree. So if that is less than 2, that is if it is 0 or 1, then it is sure that our answer is not possible. So that's why return 0. Otherwise, if we have run a loop and none of the guys are there whose degree is less than 2, then our return 1, right? Let's submit the code and let's see the output. So correct. So yeah, all the test case is passed, and as we are taking an adjacency list, so for storing that we are getting a time complexity as order of e plus that is vertex plus edges, right? So this was everything about this problem. I guess everyone has understood this, and yeah, you can also solve this problem using an articulation wala method, articulation point, finding the articulation point, wo wala part, right? I think that will be more efficient, I guess, because it can happen that some test case can fail. Like here I saw all test cases passed because there's only 10 test cases, but I guess, like, tell me in the comment section, like, in what kind of test cases this can fail, right? Because articulation point wala part is the सबसे best part, right? So that is the strongest solution. So yeah, you can solve with that as well, but this was the easiest, so I showed you. So this was everything related to today's video. I guess you have understood everything. If you have understood, then please hit the like button and also press the bell icon so that you will be notified first when we upload our new videos, right? So yeah, let's meet in another video. तब तक के लिए bye bye. बच्चों, आई होप आपको ये लेक्चर पसंद आया होगा। एक लास्ट इंफॉर्मेशन जो मैं आपके संग शेयर करना चाहता हूं, जो कि बहुत जरूरी है, दैट इज इंट्रोडक्शन टू न्यूटन स्कूल, जिनकी मदद से हम ये वीडियोस आप तक पहुंचा पा रहे हैं। न्यूटन स्कूल बेसिकली एक ऑनलाइन लर्निंग प्लेटफॉर्म है जहां पर आपको इनके फुल स्टैक डेवलपमेंट कोर्स में एनरोल करके आपकी ड्रीम जॉब्स प्लेसमेंट पा सकते हैं। एंड द बेस्ट पार्ट इज दैट यहाँ प्लेसमेंट लगने तक आपको कोई फीस नहीं देनी होगी। यहाँ पर आपको लाइव क्लासेस, इंडस्ट्री प्रोजेक्ट्स, मॉक इंटरव्यूज और पर्सनल मेंटरशिप जैसे अमेजिंग बेनिफिट्स मिलेंगे। सो चेक out the link in the description to skyrocket your coding career with Newton School.